What's up, guys? So in this video we're going to have an introduction to some statistics. And the thing about statistics is that you got to be patient sometimes, and you got to let concepts develop. So you can't just automatically jump into a concept you want to know about without making sure you have a really solid foundation on some previous topics and some previous vocabulary. So, it's kind of like building a building. Got to have a really good, solid foundation. And a lot of times that foundation just doesn't come together in a day. You have to kind of be patient with it. So today what I want to do is I kind of want to set a solid foundation and eventually set up a discussion where we can talk about probability distributions. What is a probability distribution? And then we can look at really two main kinds of probability distributions. First, we'll take a look at a discrete probability distribution. You can kind of see an example on the screen there. And then eventually we'll take a look at continuous probability distributions. But first, let's see if we can kind of get a foundation. So in statistics, a lot of times what we want to do is we want to take a look at a group of individuals. Now, individuals don't have to be people. It can be like cars or machines or animals. Sometimes it is people. But we want to take a look at a group of individuals, we'll call them, or cases, and we want to get characteristics about them. And we want to see how likely those characteristics are. So characteristics in statistics are called variables, and which is a little bit different because in algebra variables mean something different, but in statistics variables are just like characteristics. So there's two main kinds of characteristics, or two main kinds of variables. We got numerical variables. Sometimes those are called quantitative variables. So those would be like, I wonder how old the average individual is in our population. That would be numerical, right? Because you measure your age with a number. The second kind is not numerical, but categorical. So that would be qualitative. So categorical would be like, okay, so what county does the individual live in? What type of shoe do they wear? What school do they go to? All right, so we got two types of variables, numerical, categorical. Those are sometimes called quantitative and qualitative variables, right? Interchangeable vocabulary. And those are all characteristics about the individuals or the cases in the population. So we know what variables are. We know there's two types of variables, and they describe characteristics about the population. Those characteristics are called variables. Okay, so now those variables, if we have population data, in other words, if we have information or data from the entire population, then we can create what we call a probability distribution. And a probability distribution tells us two things. It tells us, well, what kind of values did we observe from the population? So if I'm looking at the age of the population, right, I can look at all the different ages. So what ages did I observe? Some people in our population might be 0 years old if we're measuring in years, or some of them might be 100 years old. And then every age in between would be a possibility. Okay, so it tells us what values did we observe. And then it would say, well, what's the probability that we observe those values? And you can imagine that some ages would have a higher probability of being observed than others. It's probably a very low probability that you would observe somebody that's 100 years old. There's not too many of those individuals around. They do exist, but the probability of observing them isn't very much. So that's what a probability distribution tells us. It tells us what values do we see in our population, and then what's the probability that we would observe those values. And remember, this comes from population data. So we are getting a parameter from our population. A parameter is just a numerical description about a population. So that's what this probability distribution does. So the probability distribution looks at different variables. We already talked about variables, and it looks at the possible outcomes with their corresponding probabilities. So there's two types of probability distributions. The first one is called a discrete probability distribution. The second one is called a continuous probability distribution. So what's the difference between discrete and continuous? Discrete means that when we look at a variable, when we look at all the possible outcomes can only take a finite number of outcomes. So the example on your screen says this. It says that Here they don't give us a probability distribution. We're going to have to create that ourselves. That's kind of the task there, but it gives us a frequency distribution. So it doesn't tell us the probability of these individual outcomes. It gives us the frequency of individual outcomes. But nonetheless, let's look and see what we got. It says the frequency distribution is shown above. The number of televisions per household in a small town. Okay, so what's our population? Is all the households in a small town. Okay, so we have all the households and we collected data and we said, okay, well, how many TVs do you have in your household? And some households answered and said, I don't have any TVs. And then some said, I have one TV. Some households had 2 TVs and some households had 3 TVs. There was no other outcomes. There was no way that an individual household could have said, I had 1.5 TVs. That's impossible, right? There's only a finite number of possible outcomes. In this case, 0, 1, 2, 3. Notice that there was no possibility of anything between 1 and 2 TVs, or 0 and 1, or between 2 and 3. Discrete probabilities are called countable, right? So if I wanted to know like the number of TVs in my house, I would go around and I would count 1, 2, 3. What else is discrete? The number of chairs in this room. There are 1, 2, 3 chairs in the room that I'm sitting in. Number of siblings, right? How many siblings do you have? You can't have 1.5 siblings, right? All right, so that's countable. Countable is a discrete measure. There's only a finite number of outcomes. We'll talk about continuous in the next video, but continuous is not countable, but it's measurable. That would be things like height. There is possible outcomes between 0 and 1, right? Let's be more realistic with height. There is possible outcomes between 5 feet and 6 feet in terms of height. So I might measure somebody and they might be 5 foot 6 inches. Or maybe I might get more precise and say they're 5 feet 6.5 inches. I could even get more precise. You can get infinite amount of precision with things that are continuous. That means that there's an infinite amount of outcomes. Even an infinite amount of outcomes between 5 feet and 6 feet when you measure people's height. But that's not what we're doing in this problem. We got a discrete measure because you can only have a finite number. There's no other possible outcomes between 0 and 1 televisions, between 1 and 2, and between 2 and 3. In this case, the only possible outcomes is 0, 1, 2, and 3. Okay, so what they want us to do is they want us to take this variable. What's the variable? The variable is, what we're interested in with this population is, how many TVs do you have? So that's a numerical variable, that's discrete. And they didn't give us the probability, but they gave us the outcomes, right? And the corresponding, not probabilities, but the corresponding frequencies. So what we got to do is we got to see, well, how many households were there total? So let's add them up. So that's what I'm going to do on my calculator, is I'm going to go ahead and add them up. I can show you in my web browser here. Well, I don't think I can actually, but I could. I think it's just going to be easier if I just add them up. So I'm adding in my calculator 20 plus 450 plus 727 plus 1,405. So the total number of individuals would be 2,602. Okay? Now, how do I find that probability? Is I take the total number of households. I'm going to divide that by the individual count for the number of households that have, in this case, 20 TVs. So my total number was 2,602. 2,602. And I'm going to divide that by, let's see if I can do that. Divide that. Let's get the fraction first. 2,602. Divide that by the individual value. And then I'm going to convert that to a decimal. I think that they want that to 3 decimal places. But this is just to show you how I'm going to get the decimal. I'm going to take each individual value and divide it by the total possible outcomes, number of total possible outcomes. Okay. So this gives us a probability distribution from a frequency distribution. All right, so that should do it. There's my probability distribution, okay? And I want to get that as a decimal. And I could do that. Okay. Actually, let me go ahead and do that. I'm going to pause the video and go ahead and get those probabilities as decimals for you. You know what? I was going to convert those for you, but I think this is a good teaching moment. So one of the things that you can do is you can upload these in a statcrunch over here on the right-hand side of the data. If you click that, you can upload that in a statcrunch. And then you can get that data in a statcrunch, and there is the frequency distribution. A distribution just tells us what values did the variable take, and then how often did it take it. A probability distribution would replace the frequencies with probabilities. So let's see if we can get corresponding probabilities over here in the third variable. Let me talk about the probability here. And what we can do is we can take this data and we can, I think that we can have a calculator here. Let's see, where do we get that calculator from? So let's see if we can get the probabilities over here using statcrunch. So if you would go to Data, Compute, and then we can put in an expression. What we want to do is we don't want to do the televisions. That's not where the data is. The data tells us how many houses we got. So let's build an expression. So let's take the frequency of households. We'll add that column up here in our expression, and then divide that by the total number. So what that's going to do is it's going to take the household of each number of TVs and then divide that by the total. The total was 2,602. And then it's going to put it in a new column for each value. So we'll go ahead and add that. We'll hit OK. And then we will, I guess we could do that, call that the probability. And then hit Compute. It put it over here in the fifth column. And that's okay, but that gives us the corresponding probabilities that we can put into our homework. You can actually just cut and paste that as you can see. All right, so I would cut and paste that into there. Okay, but something else that statcrunch can do that's going to be helpful later on is it can give you the mean and standard deviation using a calculator. So what we're going to do is we're going to go ahead and hit Stat. Remember, this is a discrete probability distribution. We're going to go to Calculators and go all the way down to Custom. Okay, not that. Sorry about that. Stat, Calculators. Okay, there's the custom one. All right, so where are our values at? Our values are the TVs. And then where are our weights at? We want the probability of those individual television values. So we'll go ahead and hit Compute. And there it is. That is the mean and standard deviation. So the average, a typical house would have somewhere between 2 and 3 TVs, right? And then a typical deviation would be pretty close to 1 television above or below the average would be a typical deviation. And then you can also do probabilities. So the probability that somebody has has less than 2, right, or between 1 and 2, you can calculate probabilities from the discrete probability distribution. Okay, in the next video, we'll talk about continuous probability distributions. Hope this video helped. Talk to you next time.